Declan, if you can hit it. I'm going to let audiovisual work on this. I can see when it's popped up on the screen. Thanks so much for the introduction. Thanks for inviting me. This is actually the first time I've been in Ireland for 30 years. I was here as a university student. Actually, I was in Edinburgh, Scotland as a university student. But this is the first place that I stopped after I got back. I'm going to keep talking because I see the audiovisual guy with a grim look on his face walking down the, so I'm trying to remember some dance moves. No. So my background originally was in technology. I used to work as a technology consultant. How it worked out. In the intervening time, I've worked for the Centers for Disease Control. I had about a 15-year career working for them in public health, and more recently I've worked in technology for public health and in artificial intelligence, both for clinical medicine. Through my practice in the United States, I do a bit of clinical practice. I also continue to work in global health, as was mentioned. I think I'm able to give you a broad outline. We were joking, or I was joking in the in the intercession about I'm not going to give you the 30,000 foot or the 10,000 meter view. I'm really going to give you the 100,000 or the 3 miles high view, because I think it's important to get some context about where this big data and artificial intelligence, where they've come from. I'm going to address this in 4 quick chapters, and the chapters begin with a discussion of something many of you, I'm sure, in this audience have heard of: disruption or technological disruption. The second one about consumerization of technology, the third about its application to healthcare, and then the consumerization of health. And my goal in this talk, it's a very sophisticated audience, people have many different backgrounds. My personal goal for the day is to learn something myself. My goal for the talk is to give you at least one thing, one important insight or concept that you didn't have when you came in to sit down. So we'll start with a little bit of a review of disruption history. Now, how many people in the audience have heard this term, disruption? Almost the entire one. How many people in the audience, raise your hand if you think you know what technological disruption is? Okay, so about 1/10 of the people who raised their hand. And how many people know who Clayton Christensen is? Okay, no one. Fantastic. So let's begin. I love this quote, and a lot of the stuff that we do in technology kind of hinges around this. What is it that people actually want, right? Which is often not the technology we provide, it's really some sort of end product. So keep this in mind. Now, this will be, I'm sure, one of many, many lectures on health data that begins with a talk about steel making, but bear with me. Let's go back about 100 years. This is an integrated steel mill. This is the way that all steel used to be made from the early 1800s. This happens to be in upstate New York. I'm a New Yorker myself. And 100 years ago, steel was made, it was dug out of the ground, or iron ore was dug out of the ground, and brought to a place like this. About 200 different buildings, about 10,000 different employees, and they were able to do anything that you could possibly imagine, make any possible end product of steel. This is something that came about in the 1960s called a mini mill. This is another way to make steel, and it takes one building and tens, rather than tens of thousands, of employees. And importantly, it made steel out of scrap, out of something that people previously thought was of no value. And in fact, when integrated mills first came out, and then over the course of time, they developed a lot of techniques to deliver every possible aspect of steel, from the roughest steel, that's the bottom right, that's called rebar. I'm sure you've seen this at construction sites. It's sort of out of sight and out of mind, but is the underpinnings of every concrete building that we see, all the way up to the finest quality steel, which is the surgical steel. Mini mills were not like that. They were using recycled steel and melting it down and repurposing it. And so there were so many impurities that when they first came out, the only thing they could do was the most primitive type of steel, the rebar. But a funny thing happened over the course of 50 years. Over the course of 50 years, the mini mills got better and better at making steel, And in fact, they learned how to make almost every type of steel that the integrated mills could make. But because they employed far fewer people and they had far fewer buildings, it was much, much cheaper. And you can see that over the course of 50 years in the United States, and it's much the same for Europe, about 60% of steel production was taken over by these new mini mills that came out in the 1960s. And in fact, the large majority of integrated mills in the United States, though they had scoffed at the mini mills when they first came out, they said, oh, these guys don't even know how to make surgical steel. All their products are at the lowest possible end. We're actually happy for them to do that low-end stuff for us because we make more money on the high-end steel. We're happy at this development. But they weren't happy 50 years later when most of them had gone out of business. This is actually a famous case of technological disruption that was described first in a book by a man named Clayton Christensen, who's a Harvard Business School professor. If you haven't read the book, and I think it seems that no one has, I couldn't recommend it more. I mean, it's sort of the Bible of technology development and technological innovation. Every CEO of every technological company that you've ever heard of knows this book and understands these concepts. And the basic concepts are that a disruptive technological product, it's not enough for something to be new, right? It has to be, first of all, generally cheaper, right? The new steel, these mini mills that came out, they were worse than the existing product in many, many ways, right? They weren't better, right? And so they were laughed at. The incumbents, the integrated mills, laughed at them and they said, oh, this will never take off. You guys can't even make the top-end steel. So the disruptive product doesn't have to be better. It just has to be better along some parameter, usually cost, usually because it's cheaper. And keep this in mind as we move the discussion a bit later into health. Again, the important part, as you saw in that graph, is that these disruptors get better over time because they make a lot of money. They take that money and they use it to improve their techniques, and they move up the value chain, as it were, until the people that were laughing at them, the integrated mills like US Steel, are almost completely driven out of business. And I've just listed a couple famous examples of disruptive innovation on the left-hand side. The Volkswagen Beetle, when it first came out, was completely, mercilessly mocked as being a very, so inexpensive, so cheaply made. But the fact is, it was good enough. It got you from point A to point B. And for many people who could never afford to have a car before then, this was their first entry into being able to have the kind of freedom that comes from personal transportation. Netflix, another great example. I don't know if, I know Netflix is present in Ireland and in the UK, but I'm not sure if it was at the time when they were sending red envelopes around. Did they have that here? Okay, so in the States, when Netflix first came out, it wasn't a video streaming company. They mailed you, by postal mail, they mailed you DVDs, right? So people just laughed and laughed at this idea. They said, when I want to watch a film, I'm going to go to a movie, I'm going to go to a theater, and I'm going to watch the film now. Or I'm going to go to perhaps a video shop, and I'm going to rent it now. I'm not going to wait 3 days for you to send it by postal mail. The only value of Netflix at the time was that it was cheaper. And a lot of people said, wow, I could use the opportunity to save a bit of money on seeing all the films I want to watch, and they did that. Of course, they got better and better and then became the streaming behemoth that they are today, which really has nothing to do with that original product. And all those video shops that were laughing at Netflix in all the movie theaters, well, many of the movie theaters are out of business, and I don't think there is a video rental shop anywhere in the United States anymore. I'm not sure about in Ireland. Now let's move ahead from 100 years ago back to about 10 years ago. And 10 years ago, if we think about what was happening in Ireland, I'm looking around the audience, but I think everyone here was alive 10 years ago. When I get to the 25-year mark, some of the audiences I speak to, you realize that I have to talk about their parents, but not with this group. So 10 years ago, politically, Bertie Ahern was and I was coached in this pronunciation by my taxi driver yesterday, was the Taoiseach at the time. In the United States, we had George W. Bush, a man I never thought I would fondly look back on. But I do. The Departed was named the best film won the Academy Award. And of course, technologically, some of the things that we use today were around back then. Twitter was just released in 2007. It was launched along with Windows Vista and Google Calendar. Another sort of cultural milestone, South Park was finally dubbed into Irish. I'm sure you remember that development. And many of you, I'm sure, when you went out to get a film, you got the DVD at a video shop. and you didn't stream it online, right? So this has certainly changed. Other things are kind of in between. I don't make any payphone calls. I haven't touched a payphone in a long, long time. But I work in a hospital sometimes, and in a hospital we still, in the United States, use fax machines every single day as probably the most common method of transferring data. And thumb drives have been awfully persistent. But I never see these dedicated GPS devices around. But one thing that isn't really around anymore, but was at the center of technology 10 years ago, was this device, the Blackberry. Now, how many people in the audience had a Blackberry? By the way, I'm judging your social status as I see that, because Blackberries were, for the very cream of the crop back 10 years ago. Blackberries were the center of business mobile computing. And it just seemed as if they were going to reign forever, although we know in retrospect that they did not. Now, at the time, 2007, there was a consumer mobile sector, but it was basically the devices that they had were sort of flip phones and candy bar phones. You could make phone calls, but no one in the business mobile sector was worried about competition from the consumer mobile sector. Not at all. But over the course of time, though everyone expected that the Blackberries of the world were going to get bigger and bigger and bigger, and then probably move in and take care of the consumer mobile side as an afterthought, that wasn't really what happened. No. Over the course of time, as we all now know, consumer mobile exploded. The point here, the important point, is that, well, I was going to say no one saw it coming, but some people actually did see it coming. I didn't see it coming. Most people didn't see it coming. They expected that business and institutional software and technology was the lead, had always been in the lead, and would continue to be in the lead. They never expected that, again, that business mobile, 10 years after this, would be adopting consumer mobile, right? People would be bringing their own devices into institutions rather than the other way around, rather than the institutional stuff being dumbed down for the consumer side. Now, 2007 was also important in a business sense for Nokia and Blackberry, who were the two leading mobile companies at the time, two of the largest companies on earth at the time, two companies that were going to be on top forever. And in fact, their revenue showed it, because that year was the combined revenue was the highest that it had ever been. 75 billion US dollars they made that year. It was also relevant that year because it was the most money they would ever make in a year. That was the peak of BlackBerry and Nokia's revenue. And I think people in Ireland nowadays know why that was. It was because the iPhone was also released in 2007. And the iPhone, when it got released, unleashed this new behemoth, Apple, which had been a $20 billion a year company, and is now, as you can see, and this is out of date, it's about a $250 billion a year company now. And of course, Apple didn't just knock out Nokia and BlackBerry. Apple, with the iPhone, and then with the Android phones that came out afterwards, also revolutionized photography, right? Apple is now the leading photographic company on earth. They sell more cameras in iPhones than Nikon and Canon and all those manufacturers who are all losing business left and right. They disrupted taxis, they disrupted news and television and music, and there's a hint that they might be, at this point, disrupting health. And you knew that eventually I might bring the conversation back to health, and I will, I promise. When Steve Jobs introduced the iPhone at a conference in California back in 2007, he quoted the great Canadian hockey player Wayne Gretzky and said, "I skate to where the puck is going to be, not to where it has been." And what's interesting to me about this quote, again, I mentioned that when consumer mobile blew up, I didn't expect that to happen. No one I knew expected that to happen, but Steve Jobs did know. He knew where the puck was going because he knew where it had been and what its trajectory was, while the rest of us were just sort of living in that world and not looking around and seeing the larger trends. So in the next section, the next chapter, we're going to talk about what those larger trends were. Because what we see today with big data and what we see today with artificial intelligence is not just some latest thing that's just popped up. This is the continuation of a very long, at least decades-old trend that one could have looked at, and in fact, some people did look at 100 years ago and predict what would have come to pass today. As you can see from this rather astonishing quote from Nikola Tesla, a Serbian immigrant back 100 years ago to the United States. As you may know, he worked to revolutionize power transmission and generation, had a lot of ideas about a lot of different things, but I find this particular quotation from 1926 to be pretty stunning, especially a man will be able to carry one in his vest pocket. This is from 1926. So again, if you think that these are things that just pop up out of nowhere, no, they don't. Nikola Tesla and then later Steve Jobs knew where the puck had been. Now, if we look at all the technology that's come up since the time of Nikola Tesla, about 100 years, and we arrange it in chronological order, we can see there are certain trends, if you will, that you can notice from this. First of all, you'll note we use a lot less wood in the manufacture of electronics than we did at the time. For some reason, 75 or 50 years ago, it was very important that only women, believe it or not, only women were allowed to operate computers back then. Somehow we've gotten to the point where we think that only men now can be good at computers. Absurd, isn't it? Because the original computer operators were all women. If you've seen that film, what is it, Hidden Figures, then you know a little bit about this as well. But the really important trend, which reached kind of a tipping point in the 1970s, was the fact that up until the 1970s, everything was kind of moving toward a situation, right? It was moving from a situation where only institutions had computers, right? Individual people didn't have computers, not even small businesses had computers, just institutions. And in the 70s, this started to change. It started to be that, yeah, large companies had computers, but also we're going to move into the situation where we'll sell them to individual consumers. And then we move to the situation we have today, which is that the vast majority of information technology equipment that is manufactured on Earth in 2018 is for the consumer, right? The enormous majority, that's whether by volume, by weight, by revenue, by sales figures, most computers that are manufactured have nothing at all to do with governments, universities, giant corporations, nothing like that. It has to do with the technology that they hope to sell directly to you. And one asks, well, how did this happen? So there are three developments, and it's a bit arbitrary because you could look at a lot of technological developments over the course of the last 50 or 100 years, but these three I think are particularly important. The first is the development of storage. This is a Danish inventor named Valdemar Poulsen, who back in 1900, right, almost 120 years ago, this is the guy who figured out how to store data magnetically. Right? This is the guy who invented magnetic storage. And in fact, he knew Tesla, he didn't know Edison, but they corresponded, they knew of each other. And unfortunately, Poulsen was a great inventor, but he wasn't a great innovator. And what I mean by that is he came up with the idea, but he couldn't figure out a way to make it practical. And that took about another, maybe about another 50 years for engineers at IBM to come up with a way to commoditize. This is under the same patent, the same 1900 patent. In fact, many of your devices that you use today still reference that 1900 patent for the magnetic storage of data. Well, IBM engineers back in the 1970s, they figured out a way to, again, create a mass-producible form of magnetic storage called the floppy disk. This is not what I started with in my computing career. My first computer was at a public library in the town where I grew up, and the storage was, believe it or not, a cassette tape. I can't even, thinking back now, I have no idea how that even worked. But a few years later, when I was at university, we began using exactly these floppy disks, which because, right, it wasn't the idea, which had come up 100 years before, or 50 years before this. It was because of the idea of how can we get these into the market? How can we mass produce these? That drove down the cost of storage from $1 million back in 1970. And of course, it wasn't really $1 million per gigabyte in 1970 because there was not a gigabyte of storage on Earth in 1970. Right? Many of you have flash drives in your pocket. That has more data storage than the entire capacity of planet Earth back in 1970. But if we extrapolate, it would be about $1 million. And today, you can buy the same gigabyte of data for less than $0.25 US. And that, remarkably, includes the shipping to bring it all the way from China to Ireland or to the United States. Building on the mass production of storage came the personal computer, and this is one of the first original personal computers, is the Apple II. There were many different groups or individuals working on personal computers back at this time in the late 1970s. One of them was the two Steves of Apple Computer, Steve Wozniak and Steve Jobs. And they developed this Apple II, which was an enormous, enormous hit, both for personal use and also for businesses. And it launched the personal computer revolution. But looking back now, over the course of this time, back to the late 1970s, the most important part of the personal computer revolution that we can see from that graph quite clearly is that it is on its way out. Personal computer sales, even though we, at our age, think of personal computers as being the center of computing, right? Even today, even though we've all got smartphones, we still think of this as being very central to computing, but sales of personal computers, laptops, desktops, have been dropping steadily for 10 years. Now, of course, it's not that we've stopped computing, it's those other even more personal computers that are extending this graph higher than the so-called PC, the so-called personal computer, ever did. And you can see that personal computers, they never reached a year where they sold 500 million personal computers in a year, but we sell that many mobile phones every single year. The only thing that was left after the development of these even more personal computers, or the original PDAs that we had back maybe 15 years ago, was connecting them all. And this fellow, Martin Cooper, who worked for Motorola, developed not only the first mobile phone, which was about the size of a shoebox and weighed about 3 kilograms, cost I think about $3,000 or $4,000 US at the time. He also invented the sort of packet switching, the cellular technology that enables these to communicate over the course of distance. Probably more important than the technology is what it has wrought, which is a world in which in Vietnam there are 120 cell phones per 100 people in the population. Even in a country like Kenya, where I travel often, Kenya's at this point, I'd say, edging into the middle income country level. And in Kenya, again, more than half of the population are walking around with a supercomputer that would have been impossible to purchase 20 years before, even if you were the king of Saudi Arabia or NASA or the US military. And now even the most common people in the world, people with very little disposable income, are able to afford this. So these three developments set the stage for what we see now by creating a virtuous cycle whereby cheaper components enable them to sell more devices to more people, not just to institutions. Those more sales, the more you sell, the cheaper the components become, and you wind up with this virtuous cycle that drives the production of something that they didn't really anticipate as being the most important thing of what they were doing, and that is more data. It is because of consumerization of technology that we have big data, right? It is because of consumerization of technology. Even when you're talking about institutional data, even when you're talking about genetic data, stuff at the NIH, et cetera, it is the consumerization of technology that has enabled this to happen by driving down the price of computing and storage and connectivity to the stage when the National Institutes of Health in the United States can even afford to play in this game. How much data are we talking about? Well, let's imagine all of the data, all of the information ever recorded since humanity first began wielding some kind of piece of chalk or scrolling something against a wall or painting in some kind of a cave. If you imagine all that data from the Beatles to the pyramids to the Mayan calendar, that is about 5 exabytes of data, 5 billion gigabytes of data, the sum total of all the data produced by humanity since there was a humanity. And ladies and gentlemen, in the world, we will record 5 exabytes of data today, 5 new exabytes of data today. And in fact, we'll do that every day of this month, and we'll do that every day of the year. Since the iPhone was released, and it's not exactly only related to the iPhone, but really the smartphone has kickstarted this enormously. In the last 10 years, we've begun producing something equivalent to all the data that humanity had produced every single day. And this process is even accelerating now. And of course, this is the big data that everyone is talking about. And again, important, especially at a conference like this, and I'm quite interested to hear some of the other speakers talk about big data, specifically in health, down at the very, let's say, workaday level. But it's important to remember that big data is driven by the consumerization of technology. It's not driven by institutional data use. Now, big data, again, is really a pretty new phenomenon. If we look back about 7 years, right? This is just a few years after the smartphones became available. And you looked at this McKinsey report. I remember reading this. And the emphasis of this McKinsey report, they talk about big data and how important it is and how amazing it is. But the real emphasis was the fact that what you couldn't do with it, right? That most people couldn't analyze it, that you couldn't do stuff with it, right? The essential part of the definition of big data just 7 years ago was it was hard to do stuff with, right? That is beyond the ability of typical databases. But if you look online and look for a definition of big data today, you'll find that the definition has completely changed. McKinsey has not, unfortunately, written a report in 2018, which would have been perfect symmetry for this talk. But if you look online for a definition, you see that now the definitions just talk about, oh, and by the way, you can analyze this. Oh, and by the way, you can use this. So what happened since we began generating all this big data? What happened to move from it's beyond our ability to it may be analyzed, or it's almost an afterthought. We assume that we can analyze it. And that's where we begin talking about artificial intelligence. And of course, here I am specifically talking about sentient robots that may or may not endanger us and take. No, I'm not talking about sentient robots at all. We're not talking about general artificial intelligence or anything at all like that. I'm sure it's decades away. And I mean, if it will ever come, if it should ever come. No, we're talking about something very, very much more limited, though powerful, and that's narrow artificial intelligence. This is where we can get a computer system to do something that formerly required a human, not something physical like automating a mill. We did that not very far from here, some hundreds of years ago. We're talking about mental tasks like image recognition. And I can think of no better illustration of the difficulties of image recognition, difficulties for which billions of dollars were spent by organizations like the US military over the space of decades to fruitlessly try and solve the problem that is represented in this image, that is the difficulty of distinguishing between blueberry muffins and chihuahuas in images. And frankly, I mean, I'm a bit closer than you are, but for some of these, I'm not sure, right? I'm not sure. Again, literally billions of dollars, maybe even trillions of dollars spent fruitlessly trying to do this using old methods of what were also called artificial intelligence or branches, called expert systems. Expert systems is the kind of programming that all of us are at least familiar with in concept. The idea you write an algorithm, and it's a human writing the algorithm. You write a decision tree, something like if the number of dark dots in the image is divisible by 3, it might be a chihuahua. If it then has maybe a dark line underneath that, maybe that's a chihuahua, that kind of thing. And you can imagine trying to write that algorithm for that set of images, that it was never very workable, that it never worked very well. And in fact, never got really beyond the flip of a coin. The US military was particularly interested in image recognition even back in the 50s and the 60s, because in the Cold War, they were trying to develop self-driving vehicles, especially self-driving tanks. And they never could get beyond the point of teaching the tank to know what was the road and what was off the road, especially when you're driving in a place that might have dirt roads or tarmac roads or other kinds of roads. They just couldn't do it. They basically shelved the idea, because even with that amount of money to throw around, they just couldn't do it. The new approach is quite different. The new artificial intelligence, much of what you hear is based around a concept called machine learning. This is very loosely based, I'm sure many of you know this, on the way the human brain operates, the way that neurons operate. But the idea here is that you take lots and lots of data. In this particular case, you might take lots of images of chihuahuas and label them as such, lots of images as blueberry muffins, label them as such. You feed that into the learner, into the artificial intelligence program, and it writes a second program, right? It writes a second program, and that second algorithm is what enables you then to feed it a new image, one that hasn't been labeled, and it can do that. And this, again, we have consumerization of technology to thank, because we wouldn't have all this data, and we wouldn't have all these very fast processors that are required to do this if it wasn't for the huge markets in selling computers to every person on Earth. So thank you, consumerization, for that. Now, the problem with this is that that second algorithm that's derived is often a black box. It's often difficult, sometimes even impossible, for humans to understand or to read, to discern exactly what's the decision-making process. What is it that the AI learning algorithm, what is it that it saw in there that defines chihuahua-ness or muffin-ness? How does it make that distinction? In many cases, we, at this point, and people are working very hard on this problem, we just can't tell. Probably not so important for chihuahuas, because the bottom line is that this works so well that when you're talking about image recognition, everyone's willing to not worry too much about the black box issue. But I know we'll be talking during the course of the day about ethics. And when you're not trying to label, for example, an image as a dog versus a muffin, but you're trying to label someone as creditworthy or not creditworthy, or a security risk versus not a security risk, then the black box nature of current artificial intelligence, current machine learning, is in fact, makes, I think, people who are interested in ethics and privacy quite queasy. So people are working very diligently to try and find ways to be more explicit, to have the machine be more explicit when it does this. But again, right now, people are just thrilled that it's moved us beyond the early stage when we just couldn't even get to the stage above 50 to 60%, above the flip of a coin when trying to do things like image recognition. Now, importantly, for the purposes of health and everything else, the more data that you put into that black box, the better the result is. This can be a limitation, of course, right? We find that in health, in some things we have data we can use to train AI, in others the data's messy or we don't have it available. And so AI is getting better, certainly, faster in the sectors that have most data. Now, I'm not sure if everybody thought about this before the lecture, but I know now I don't need to give you any kind of a hint for you to understand what sectors AI is getting better faster in, because what sectors have all that data. And that is, of course, the consumer side. I love when people talk on the medical side. I get into conversations with people all the time about whether AI will actually work, about whether we'll be able to use AI, about whether AI is overhyped, when in fact we're swimming in AI every single day. We use AI, our phones use AI, the network uses AI, the stores we shop in use AI every single day. I tell people, if you want to know what's going to happen technologically in healthcare in the future, just look at what's happening in retail today, right? Because retail and other consumer-oriented technologies are on top of this. Whether it's Netflix recommending films for you, or Pandora, or Amazon. Do you know that Amazon is actually floating a possibility that they would have a service where they just send you things they're very sure you want before you order them. They actually are thinking of switching it around, that some of their users would simply receive a box maybe once a week, and then you could return them, postage paid, postage free, return the things you didn't want, because they're so sure at this point that their AI knows what you want to buy. And anyone who's ever, initially with Amazon, when they first started recommending books, I found it kind of irritating, because I thought, how can they possibly know what kind of books that I find interesting? And then after a while, you realize, apparently I'm completely transparent, because every single one of these books looks interesting that they're recommending to me. Now, I read a book myself, which was in fact recommended by Amazon, about AI called Prediction Machines, and I think it gives us a good framework to think about how AI works. It describes personal computing, right? As technology reached the stage where we could start selling to consumers, that personal computing was a revolution in cheap math, in doing mathematics, right? Just addition, subtraction, multiplication, et cetera, doing that at a very, very low cost, much lower cost than we did before when humans had to do it. And the authors, especially Agarwal, describe AI as a revolution in cheap prediction, right? What is Amazon doing? They're predicting what you like. Netflix is predicting what you like. I think that the cheap prediction, I know what he's talking about, and I think it's a great framework, but I prefer to say it's a revolution in cheap expertise. Because isn't that what expertise is, after all? The ability to look at a situation, to see a set of facts, and predict what will follow after that. If I see a patient come into my clinic, I can look at that child, and most of the time I can say, is this a child that's going to be admitted to the hospital, or is this a child who has a cold? Right? That's what my expertise consists of. And of course, in terms of the retail side, I'm sure back in the Downton Abbey days, someone like the Earl of Grantham might have been able to employ a human expert, a librarian, to look at their bookshelf and talk to them about the books they'd read and offer advice about what other books they might have read. Of course, no one else could ever have imagined having a personal librarian that you employ, but now all of us have one, and it's so, basically it's free, and it's so invisible that we don't even think that we have one. We don't even realize that we now have an army of experts trying to help us decide. Not in health, not yet, but on the consumer side, we have an army of experts trying to constantly predict what are the things that will be most pleasing to us. Well, what about health? As I mentioned, the future of retail, or the future of health is the present of retail, so health is always a bit behind in terms of technology, but we are making some strides. So let's talk about the advent of AI in health. Now, I was giving a talk about 2 years ago, and 2 weeks before I gave that talk, a much more impressive fellow named Geoffrey Hinton, who's one of the founders, one of the fathers of machine learning, gave another talk, and he gave this quote, and I said, well, that's the quote for my talk, isn't it? It's just completely obvious that within 5 years, deep learning is going to do better. Deep learning, another machine learning technique, is going to do better than radiologists. And he was asked, but what do we do in the meantime? That might take, what if it takes 20 years? And he said, well, we've already trained enough radiologists to last for the next 20 years, but we need to stop training new ones now, because 20 years from now, we definitely won't need them. This doesn't get big laughs at radiology conferences, I can tell you. So let's see if Hinton was right. Well, this is actually from just a couple weeks ago, or actually last week, November 20th, this was published. And this article called Deep Learning for Chest Radiography, or Chest Radiograph Diagnosis. And they found, they looked at 420 images, not a huge sample size, but pretty good. And they compared this to the diagnoses of determined by radiologists and by senior radiology residents, senior radiologists in training. Oops. I'm not going to touch the podium. And they found that in this particular case, and again, this is just from last week, that the AI was better or equal to the radiologists on 12 of 15 pathologies. Now, it's only one modality. It's only chest x-rays. But chest x-rays we do a lot of chest x-rays. We pay a lot of money for radiologists to read chest x-rays. And the AI was only worse than the radiologists on three pathologies. Now, keep in mind, of course, we don't have to pay salaries to AIs, and we don't have to let the AIs go on vacation, and we don't have to have pensions for AIs either. And again, you see why this is not a very popular slide in radiology, at least not among young radiologists. What about other imaging? Dermatology, it seems, is also in the crosshairs of AI. In this particular example, which was written up not only in Nature, but in the New Yorker, in an article ominously titled AI versus MD, they found that looking at 25 expert dermatologists, I think they all had 20 years of experience, in every test, the network, which is to say the machine learning algorithm, outperformed the expert dermatologists. Another image tool, looking at fundal photographs, so looking at images of the back of the eye, trying to determine if there are the pathological changes that are characteristic of diabetes, diabetic retinopathy, and they found that they're able to get such good results that this has already been commercialized. This is the first device that has been approved by the FDA to actually make a diagnosis without a human physician. Prior to this machine, the only way you could make a diagnosis of diabetic retinopathy is to get a very, very highly trained and paid ophthalmologist to look in the eye with specialized instruments and make this diagnosis. This is not targeted at the public. You won't find this at the chemist shop, not yet anyway. This is targeted at primary care physicians in the United States and saying, if you're caring for diabetic patients, you won't have to actually refer them to the ophthalmologist. The diagnosis can be made not by you, primary care doctor, but by the machine, and then you can act on it as a primary care doctor. This is a big deal, the fact that, again, it is diagnosis without physician. Many of you, I was surprised because there was a whole to-do about my using a Mac this morning for this presentation. I thought, from the United States vantage point, I thought Ireland was all Apple mad because of Apple's operations here, but I'm sure everyone has heard that you can now, with the latest version of the Apple Watch, get an ECG, an electrocardiogram. Not only that, you can have the Apple Watch read and interpret the ECG. Again, this is also FDA approved. So for certain conditions, like atrial fibrillation, you can have your watch diagnose this. I was actually at an event in Washington recently where I have a friend who's a lawyer, and one of his clients is Apple, and so he gets invited to these events where they show some of the technology that's just come out, and even technology, which I can't talk about, that they are planning on having come out. It was the first time I'd seen this happen in person. The person who was doing it was fumbling around a little bit, and she said, "Oh, sorry, I've just got to get this right before I can do this." And I said, "That's okay. The device that we use to do the same thing in the hospital is this big on a rolling table. So, if you need 30 seconds to make it work, that's fine. It's still a miracle of science." So again, diagnosis without a doctor. And it's not only about images. People often have the idea that it is. This, to me, as a pediatrician, is fascinating. I was actually stunned when I first read this. Australian researchers are analyzing sound patterns, sound files from children coughing and children breathing. And they've come up with a system that has a sensitivity of 94% and a specificity of 75 or 79%, I think it is now. They're obviously trying to make it better. And this, ladies and gentlemen, is a smartphone app. The child breathes next to the smartphone microphone, and it makes a diagnosis of pneumonia or asthma. And again, I was stunned as a pediatrician because I thought, how can it do that? And I realized it does it the same way that I do it. It listens, and it compares the sound it's hearing to all the normal sounds it's been trained on over the course of the years, and all the abnormal sounds it's been trained on over the course of the years. By the way, I will be providing a link at the end of the talk, I should have mentioned this earlier, that has both a summary slide and also a reference sheet to these articles. Final example for healthcare, again, astonishing to me. Wobot is a company, well, it's a technology developed by a company out in California. This is another smartphone app where you text back and forth, but you're not texting back and forth with a therapist. You're texting back and forth with an AI-driven machine. And what they have found in the preliminary studies of Wobot and other similar technology, believe it or not, is that when it comes to what's called cognitive behavioral therapy, the results that happen for people with depression, right, the reduction in their depression symptoms, is equal with the AI therapist as it is with a human therapist. Chatting with the AI therapist produces the same reduction in symptoms that chatting live in person with a human therapist does. I can almost not believe it myself. The journal, I don't subscribe to this journal, but the Journal of Administration and Policy and Mental Health went so far as to say, and obviously you know where their bread is buttered, as to say it's possible to contemplate a time in the future when therapists have gone the way of bank tellers. The point is that the cheap expertise of big data and AI is coming to health and healthcare, and this is going to change clinical practice. And especially it's going to shift more of health and health research away from traditional healthcare. We think of traditional healthcare as being traditionally the center of health, but it has only been that way for about the last 150 years. It may turn out to be an aberration. And if we want to do research, we're going to have to look not only within the healthcare system. Back to Clayton Christensen, as we kind of come full circle to where we started. Clayton Christensen wrote a second book about the healthcare system in particular and said, the way that we're going to get growth and affordability in health is by embodying expertise in devices and equipment. And he wrote this even before AI was all over the world, was all over the news. So pretty impressive that he came up with that. Well, what was he talking about? Where is the data for our health? I'll tell you a story about health data, and stop me if you've seen this story before. But back in 2000, almost all health data was on paper, right? It was in non-electronic health records. There's a little tiny red dot there that represents electronic health records. In the United States, we had a little tiny, even tinier dot that represented consumer health IT. Back in 2009, the US government gave about $35 billion to hospitals to get them to upgrade to, well, I'm going to put upgrade in quotes, to upgrade to our absolutely horrific electronic health record systems that we use in the United States. And everyone thought, fantastic, now we can actually work on electronic health data, which of course is in the hospitals, in the EHRs. But I think I don't have to give you a hint to know exactly what happened and which of these circles got bigger faster. That's right, the consumer health side, right? Because of the rise of the smartphone, because of the rise of big data, most data about people's health is present outside of the healthcare system. And that might be in things like fitness trackers, which people tend to scoff at. But I was talking to a group of orthopedic surgeons and I said, they said, well, what can we do with this? And I said, 10 years ago, every one of your patients, I mean, your orthopedic surgeons, 10 years ago, every one of your patients started carrying a device around with them that they bought themselves with their own money that tracks how much they move and how far and in what direction every minute of every day. And you're asking me, what can you do research-wise with this? I mean, if orthopedic surgeons can't figure out what to do with it, I think the rest of us, we just won't be able to. But the point is that all of this stuff, not just things like grocery trackers and fitness trackers and health admin and reminding you to take your pills and all the rest of that, but certain stuff like we were just talking about, like that ResApp thing where it listens to the child's breathing, that it's pulling out of the healthcare system, like the diabetic diagnosis. I expect that that diabetic retinopathy machine is going to be present in chemist shops by the end of the decade. Right? You won't even need to go to a doctor at all. Now, until recently, people thought all this stuff, the problem was we have to figure out how to get all this data from outside the healthcare system and bring it into the healthcare system and connect it to the EHR. Because, of course, the EHR is the center of the health data universe. And why would the EHR be the center of the health data universe? Because that is what doctors look at. Doctors look at the EHR. And doctors, with their very big brains, are the only way, right? Doctors with those big brains are the only way that we can take health data inputs and turn them into health data outputs, right? That's the only way until recently we were able to do that. But as we've been learning, that's no longer the case, right? It's not just AI, it's also pharmacists. It's also people looking at Google. We now have lots of different ways. It's taking prescription medicines and making them not require prescriptions anymore. We're in the process of a long-term trend to move things away from requiring a doctor to make a diagnosis for us to act. And so I think trying to move all this health data into the EHR is really a question of looking at the dog and looking at the tail and misidentifying which is which. The fact is consumer health data specifically, is the dog. The EHR, the data we have in the hospital, is the tail. And so I realize I need to wrap it up now, although I was told I had some extra time. Let's talk about health making and bring it back to where we started. On the left is a Veterans Administration hospital in the United States, in Virginia. That is a 200-building facility that employs tens of thousands of people and can do every possible aspect of health diagnosis and treatment. On the right, we have a mini mill. This is a minute clinic where people can walk in and only do a couple different things, but they do a couple things quite well. And in the production of health, we also, of course, have a very important third producer, and that is us, including lay people. And lay people right now can only do a certain limited amount of things. But I predict that over the course of the next 50 years, what we'll see is something very similar to what happened and what we talked about initially in steelmaking. We're gradually, with a variety of tools, and again, not just big data, not just AI, but tools including, as I mentioned, government looking at prescription drugs and saying, you shouldn't need a prescription for this. Booz Allen, a consultancy in the United States, estimated that if the non-prescription medications, the over-the-counter medications in the United States, if the 10 most popular ones were made prescription again, as they used to be, that would generate an additional 500 million physician visits per year, 500 billion physician visits in the United States per year, if we were to go back to those being prescription. Freeing them from the prescription has reduced the number of clinic visits by 500 billion visits per year. It's not only that, it's Google that enables us to get some health information, sometimes the wrong health information, but health information, and now AI. Now, I don't know how many people have seen the movie Minority Report. How many people have seen that with Tom Cruise? Everybody. I love this movie because it's filmed in Washington, where I live, so I can see places in the film in the future. But I also love it because in the film, it's not one of these films about the future where everything of today is gone and completely replaced by some new future. It shows that the future happens gradually. And in fact, Tom Cruise might be in a self-driving car that goes up the sides of buildings, but at the same time, and operating his computer by waving his hands, but sometimes he drives that self-driving car to a little house by the seaside, and he sits and might read an actual physical newspaper. It is exactly this way in health and health technology. Again, people say, will AI work? Will we use AI? We're swimming in AI every day. We use it all the time. The question is not whether AI will work. The question is how quickly we can bring it to work safely and effectively and with respect to privacy and security within the health system. So I've run over a bit, but I was told that I could do that, or it was implied that I could do that. I've covered a lot of ground. What I would advise you to do, since we're going to have questions after the other speakers, is to take a picture of the slide so you'll be able to ask me some sensible questions when we get to the question and answer part. I thank you for your attention. Everybody's been a great audience. I didn't see many people looking at their watches or their phones. And again, I will look forward to answering your questions when the time rolls around. Thank you.